Hi, I'm Genevieve Sergeant from the University of Sydney, and today I'll be telling you how to light up your cells. Our bodies are really complicated. They're made up of trillions of cells, and inside each one of those trillions of cells, there's even more chemicals and proteins and biological bits. Even now, as you sit here listening to me, at a cellular level, you're incredibly busy. Those parts are working together and interacting in a precise way to keep you going, and ideally, everything is going right. However, sometimes it doesn't. Essentially, every disease from cancer to cystic fibrosis is a problem that affects your cells. In order to work out what causes disease and work out how to treat it, we need to see what's going on inside those cells. The problem is that when we get to look at a cell up close, it doesn't look like the pristine, tidy, and mostly empty cell we see in a textbook. Instead, it's kind of like a page in a Where's Wally book. Everything's packed in there. There's a lot going on and it all looks the same. So it's really hard to find Wally, or whatever the cellular equivalent of Wally is. Now imagine how easy it would be to find Wally if you did us all a favor and started wearing a high-vis vest. That's what I'm doing, not designing clothes for Wally, but designing an equivalent for the characters in our cells, especially the troublemakers. These types of chemicals can be an important tool for biologists. When we experience a sickness or some kind of problem, it affects our cells. Different types of cells, such as cancer cells or healthy cells, have different stuff inside them. So if a biologist wanted to see how a potential drug affected these cell types, this type of light-up chemical could be illuminating. In order to create this chemical torch, I make a chemical that works like a molecular light globe. This uses a special technique called fluorescence. In a normal light globe, we put energy in the form of electricity, and we get energy out in the form of light. In fluorescence, we put energy in the form of one color of light and get energy out in the form of a different color of light. This means it's really easy to find what we're after, as it is the only thing shining back at us. I try and use this to look at cells and bodily fluids like synovial fluid, spit, and urine. These have different chemicals in them, which we can use to learn about what a person is suffering from. In practice, this can be pretty difficult, so I'm spending my PhD trying to make chemical torches to solve different problems. Science is all about collaboration, and it's my hope that by making more and better chemical tools, we'll be able to shine a light on some difficult problems and create a brighter future for us all.